Okay, physics students, today we are going to do an example of how to do a convex mirror ray diagram and answer some of the math questions about it using the mirror equation. So I'm going to do this example. We have an object that's 20 centimeters away from a convex mirror. Again, this is a mirror that the edges bend away from you. It's kind of bulging toward you. And they always make things look smaller than they actually are. Again, think of the back side of a spoon. All right, so the object is 20 centimeters away from a convex mirror that has a focal point of -4 centimeters. What is the image distance Q and the magnification M of the object? Do a ray diagram and do the math. So in case you don't recall from the directions I gave in the notes and from the concave mirror examples that I did before, there are really three possible rays for you to draw here. The first one I think is pretty easy. You just draw a parallel line from the top of your object to the mirror and then draw it through the focal point. Now, because this is a convex mirror, the focal point is on the back side of the mirror, all right? Which means you're going to be drawing that line through the mirror. Ray number 2 possibility is from the object toward the focal point. Once it hits the mirror then, however, it will then travel parallel to the main axis. And then number 3, draw through the center of curvature. Now, in reality, you only ever have to draw 2 rays. You don't have to do all 3 because you're just looking for a point where they intersect, and that's where the top of your image is going to be. So let's go ahead and take a look here. I drew a picture, and so this right here is the mirror. And this is the front side where all us real people live. This is the back side. This is where virtual images exist. Okay, this side is negative. I've got -4 for the focal point, and this is P, the object distance at 20. So if I look at those 3 possible rays, again, the first one is from the object parallel to the axis. This is the axis right here, to the mirror, and then down through the focal point. So I'll take my straight edge here and just draw a ray parallel to the axis. So the ray of light's going this way. Now in reality, it's not going to go through the mirror, but it will reflect off the mirror as if it was coming from the focal point. Okay, so this is the ray I care about right here. All right, the second possibility is from the object toward the focus to the mirror and then parallel to the axis on the back side. Now, that means I'm going to try to draw it straight to the focal point here. So here comes this ray of light. Now, here's the thing though, it hits the mirror, and in reality, it's going to bounce off parallel back this way. But it's going to appear as if that reflected ray was coming from there. Now, here's my point of intersection. That's where my image is going to be. Now, the last ray, and I'm going to do 3 here just so you can see, is through the center of curvature. And I didn't draw the center of curvature, but we know that the center of curvature is 2 times the focal length. So if this is -4, I'm going to say -8 would be right there. And then I would just draw a line that goes from here straight through there, and oops, look at that. It also goes through that same point. This here is my image, and we can kind of guess that the image distance is maybe like -3. It's probably in that ballpark somewhere. And so let's figure it out mathematically. The other thing you can see is that it's obviously much smaller than the object. And I don't know, maybe that's 1/5 the size, but let's do it mathematically. Okay, so our equation is the mirror equation, 1/P plus 1/Q equals 1/F. Now, again, this is the way it's always given. I prefer to write it like this: P to the -1 plus Q to the -1 equals F to the -1, because that works so much better on my calculator. So we're going to want to find Q, and so I'm going to move P to the minus 1 over to this side. So Q to the minus 1 equals F to the minus 1 minus P to the minus 1. All right, and I don't want Q to the minus 1. I want the inverse of that. So I'm going to take the inverse of both sides. So really, Q equals F to the minus 1 minus P to the minus 1 all to the minus 1. And now I can just substitute some numbers in. F was -4, so -4 to the minus 1, minus P, which was 20, to the minus 1, all to the minus 1. So let's type that in here. So I go -4, and then I hit the x to the minus 1 button, minus 20, I hit the x to the minus 1 button, equals, and then I hit the x to the minus 1 button on that sum, and I get -3.33. And so what does that mean? First of all, it means my drawing was pretty good, so yay me. The second thing is that that negative sign means that this is a virtual image because it's existing in mirror land. Okay, last thing here is to find the magnification. So magnification can be found in two different ways, and we're going to use this way, -Q over P. And so Q, we said, was -3.33, so -Q would just be 3.33. And P was 20. Now, again, these are both in centimeters, but because they are the same over one over the other, then they cancel out. So 3.33 divided by 20 equals 0.166, let's say 0.167 for the magnification, which is 1/6, which means that this little guy here, that image, is 1/6 the size of that. Okay, that's how you do convex mirrors.